Hello, Brian Hoover here, Hooovahh on the forums. I wanted to make a video describing some of the features of the image manipulation package that I posted on vipm.io. If you go there and search for image manipulation, this will come up, and from here you'll be able to install the VIPM or download the package and install it however you'd like to. And then once you get that, on the block diagram, you'll have this image manipulation palette which is under the Hooovahh palette. The array is a dependency, so it should come along as well. And here's a bunch of functions that I have, but I want to start actually in this .NET palette first. You see, the reason I made this package originally was because I had a need to display an image that was on disk, but I wanted to show it in a dialog and let that dialog be resized. So if you resized it, I wanted the image to hold its aspect ratio, to look normal, but I wanted it to get bigger and smaller as the window got bigger and smaller and support different resolutions of monitors and such. I tried doing that in LabVIEW with zoom on the zoom level on the indicator itself, and I ended up having to cause issues with positioning, and then there's aliasing issues, and then eventually I wanted to display PNG images with alpha layer transparencies, and it became such a nightmare that I just had to give up and eventually stumbled on using .NET functions to handle this instead. So here is the demo for load image, and this is the main thing that I use a lot of today. If we look at the source code, it's relatively simple. There's just a set of controls that if we change their values, we want to load that new image with the new settings, gray out the image if we choose, display it, and then there's an event for if we change the zoom settings, an event to stop, and an event to close. But you'll notice there's nothing for the timeout case, and there's nothing for if a panel or pane has changed size. If we run this, it'll load an image from its installed location of this book, and when we resize the window, it's got this nice, very smooth resizing animation. It's fit to the entire pane, and the image is fit to that entire control. We also have a stretch mode where we can take that image and it will stretch, losing that aspect ratio. But now, at least, it'll fit to however it wants. This is the mode I generally use. You can also set the background color. So here you'll notice there's a shadow underneath this book. And if we change the color to something else, you can see that that shadow is actually still there. It's now slightly green because the background is green. Any color we change it to, it'll change. It's the same with the star up here. This is kind of semi-transparent, and we can see the color behind it. Doing this in native LabVIEW is very, very difficult. But in .NET, we just ask it to display an image, and it takes care of a lot of the heavy lifting for us. Now we can get this image data back, and then LabVIEW we can use it in LabVIEW however we like. So here we're getting this image. We're then setting the alpha layer transparency and getting the image back and displaying it. So if we gray out the image, you can see that it is now grayed out. Well, we can also gray it out in this white background. And that's because we were able to get that image data, manipulate it back, and do other things with it. This is the normal LabVIEW data type for LabVIEW images, and so you can do whatever the functions you'd normally want to do with it. But if you're just displaying it, you don't have to bother with this at all. Just load it up, display, and you're good to go. A couple of other demos that use similar functions is this rotation demo. If we run, we have this image that we can rotate, but we can also set where we're rotating, because we could start here, but we're rotating around that corner, or we're rotating around here, or we move this down, and now we're rotating around the center. And it's running pretty quickly. Here we have about 1,000 iterations of our loop per second. And the code is very simple. Load up the image, load up our rotation, tell it to display, and keep going. And then this is telling us our loop rate. Similarly, we have a zoom demo. And if I run that, We can zoom in. Oops, we can zoom in, or we can move where that point is that we're zooming in on, and then zoom in somewhere else. And this is also running at around 700 iterations per second, and the code looks very similar. Tell .NET to rotate or zoom the image, and then display it, and then just keep going. This is all possible in native LabVIEW code, but it's with a lot of math and a lot of memory. But here, we can just offload the heavy lifting to the .NET functions, which is built into Windows. This is a lot of the functions that are supporting these three demos. But there's a couple of neat stuff in here as well. Like here, you get an image from a handle. So if you have a handle on a window or the window title, it'll return to you an image of that. It's like taking a screenshot of just that window. Going up a palette, we actually have a take screenshot function, and this works in a very similar way, where we can tell it which monitor are we taking a screenshot of. And this is all using .NET functions under the hood. So getting the screens, finding the source, displaying it, saving it, and returning it. So yeah, you could, if obviously this is meant for a computer with just two screens, the left and right, but here you have all screens, and then you can figure out which one you actually want. Here is GDI resize is a really good one. That's basically resize an image. Give it a path to the image or image data. Tell it the size that it's going to be. Give it a background color, which is important only for images that have transparencies or background layers like PNGs might. Other images like a JPEG, it won't matter. And then it'll return this new image, which has been resized. Now, if we look at the code, we can see that we are creating a buffer of a certain size to hold our image, and then we're saving that into a memory stream. We return the memory stream. So right here, this is actually the array of bytes for a PNG image, and then we're actually returning that data as a LabVIEW data type. But you could just save this array of bytes to file, and now you have your PNG file been resized. So this is great for resizing anything. You could have an array of, like a folder of images turned into an array of them, open all of them, find out how big they are, resize them, resave them. There are other tools that can do that, but now you can do it in LabVIEW pretty easily using the functions that are built into Windows. Here we can create a gradient on an image. So if we have a couple of random colors and we hit run, it'll make a gradient going from the top to bottom of the colors that we've selected here using the size information that we told. Now, the reason this might be useful is it uses this linear interpolation for color underneath the hood, where you might have a fill that shows from green is good, and then yellow it starts to be bad, and then at 30 it's really bad, it's on red. Well, we can move this, hit run, and now this will change the color based on the value that it is. So we get up to 30, now we're at red. How about 20? It's between yellow and green. Now it's more green, that kind of thing. The picture constant is a fun one. This is an X node. If you drop it, it just looks like a picture constant, which it is. But we can find an image in Windows Explorer, drag it over, drop it, and now this is actually a constant that is that image. So we can create an indicator to display it, or you can do all the normal image manipulation on this wire, which is this constant. Now this was a bad example because it's a huge image, but this is great for like icons or little images that you can embed in your VI and not need to be separate files. Now, of course, there's a benefit to having them be separate files. They're easier to replace, but this is great for small things to embed in your block diagram. Masking colors is interesting for removing colors, basically, from an image. You give it an image, you tell it what color to remove, and then the output will be an image where those colors are now a mask where you can see what's behind it. So if you have an image layered where there's a bunch of images, you can see the images that are behind it. or if not, you'll see the background color. Here we are merging multiple images, and this is actually a polymorphic VI, so you can select the type. And so like here is 2 files, and this uses a lot of .NET stuff under the hood. Let me see if I can open the source. All right. So we're getting those images, we are drawing them one at a time on top of each other, and then we're saving the image as a PNG stream, and we're returning it. What's great about this is it supports all the PNG transparenciness that you would hope it does. So you can put images on top of images on top of images, and assuming they have that alpha layer information, it'll work just fine. Another fun thing about image manipulation that people might not know is the 2D picture is actually a string under the hood. So like here, we can take a string and concatenate it with another string. Now what that does is it puts it on top of it. So it'll take an image, just put another image on top and replace the pixels that it had, if they're overlapping, that is. But using this move and translate picture function, we can tell an image to actually move over a bit. So I think this is X and then Y. Yep, so I can say move over 10 pixels, and now we can put that in there. And now they won't overlap, or at least the first 10 pixels won't. This is a great tool. Norm posted it on Lava years and years ago, but it is super cool. I've used it all the time, especially in places where you might have like an array of images. So let's say we have an array of rectangles. We said make 5 rectangles, and then, well, we wanna concatenate them, but they'll cover up each other. Well, then why don't we take Norm's image shifting and then tell it to move over, say 32 pixels. I don't know how big this is going to be. We haven't really defined that. And then what we get is an array of images back out that we can concatenate all together and display. And this is great because you have these array of images, but let's say you want to replace one, which is like one section. It's like one layer in the final image. Well, you can do that. You can redraw that one image, shift it over however many it's supposed to be, replace the array subset, redraw it, and leave the rest of the images, the other 4, just as they are. It's a super efficient way to be able to replace sections of an image. And I've used this in a handful of my packages or at least example code in the past, and I hope to be posting some more demos using this in the future. Here is the PNG functions. I don't use a lot of these, but these two are very useful. LabVIEW image to PNG data and image data to PNG data. These are built into LabVIEW. They're in the vi.lib, but most people don't know about them because they're buried away. I think they've been exposed on the Hidden Gems palette, but I use them all the time in a lot of these PNG manipulation stuff. So yeah, create PNG stream from an image. So this was an interesting one. My intent was give me an image, tell me how to save it, and I will give you a stream. And the reason I wanted this is because on real time, it's kind of hard to save a PNG image, or at least there's different ways of saving a PNG image, and the native solutions don't always work. So the code is a little weird because we have all these different versions that I'm trying to do it different ways. The normal NI way is, well, here we go. Yeah, is there a compression on doing it the NI way? And this is calling NI's image data save. Well, some don't work on different platforms. So here is a little bit of compression, here's no compression, but if those don't work, we can try to do a save and then reload it, but this doesn't always work. So then we start getting creative and we're like, okay, fine, uses the zip function built into the RT target. or use pkzip if this is really crazy, but it's like save it as a file. Now open that file, find the chunks of the file, read those chunks back out, and then put that into the PNG with all this extra header information. Um, or here's the OpenGZip function. This works great if it's installed, but it's not always installed, and only the beta package supports RT targets. So this was definitely an experiment in creating the PNG file on targets that don't have a lot of support for them. I was trying to create web pages dynamically based on the front panels and then displaying those as a web page, and it just got to be a little bit of a mess. So good luck trying to use it, but there's some of the PNG functions in there that I've tried to use. So I hope this was helpful. Let me know I'd recommend coming here to VIPM.io, coming to here and posting an idea, adding resources. Send me messages if you have questions or issues, or if you have suggestions on new functions that should be added or updated. Thanks.